Alright class, so last time we started talking about compounds and we've gone over ionic compounds so far, and always go back to the basic. How do you know if you have an ionic compound? You have a metal and you have a non-metal. You have a metal and you have a non-metal when you have ionic compound. And we said the metal want to lose electron and the non-metal want to gain electron. So ionic compound is a balance of charges, and we went over all the charges and how to write and name ionic compounds. Now, today what we're going to talk about, now we're going to move on to covalent compounds. So, ionic compound, a metal and a non-metal. Covalent compound, what you have two non-metal. Is non-metal together. Wait a second, how is that going to work? Because non-metal, they want to gain, right? So now you have two atoms that they both want to gain. What's going to happen to that relationship? What they end up doing, they end up sharing electron. So what they end up doing, they end up sharing electron. They share electron. Because again, ionic, one wants to lose, one wants to gain. Perfect. These here, two non-metals together, they both want to gain. So what's going to happen? They're going to share electron. Now, because they're sharing electron and there is no losing or gaining electron, there are no charges. There is no balancing charges for covalent compound. I need you to make note of that. There is no balancing of charges for covalent compound. And how do you know you have a covalent compound? You have two non-metals. Okay, perfect. Now, here are some examples of covalent compound. CO2, N2O, B2O3. So again, you have two non-metals together, you have a covalent compound. There is no balancing of charges, right? Because no one is going to lose, no one is going to gain. There is no plus minus. They're going to share electron. Now, there's a problem. Here's a problem. If I ask you right now, here's a problem. If I tell you to write down the formula for sodium sulfate, that's an ionic compound. If I ask you to write down the formula for sodium sulfate, can you do that? Yeah, can you do it for me right now? So sodium sulfate, write down the formula for sodium sulfate. And what you're going to do, you're going to say, okay, sodium is Na, sulfate is a polyatomic ion. Hopefully you're getting used to those polyatomic ions. And then you're going to look at the periodic table and you're going to say sodium has a +1 charge and sulfate has a -2 charge. I have to cross multiply the charges because for ionic compound is a balance of charges. I don't write the 1, and then what's going to happen is I'm going to end up with Na2SO4. Perfect. Because ionic compound is a balance of charges. Now, I just told you that covalent compound, there are no charges. So if I tell you to write down the formula for carbon oxide, because there are no charges, there's no balance of charges, how would you know? Is carbon oxide CO? Is it CO2? Is it CO3? How would you know how many carbon and oxygen you have? When I told you sodium sulfate, you knew it was going to be Na2SO4 because you balance the charges. Now, if I tell you carbon oxide, how do you know? Is it CO? Is it CO2? Is it CO3? How would you know when there is no balance of charges? Do you guys see what the problem is? Ionic compound, you balance the charges, it's easy. Now, for covalent compound, there's no balance of charges. How would I know how many carbon, how many oxygen I need to write for carbon dioxide? Well, to get around that, for when we name covalent compound and only covalent compound, what we have to use prefixes. Okay? So we have to use prefixes when we write when we name covalent compound. So what we have to do, we have to use prefixes. And again, it's just for covalent compound. is just for covalent compound. Now, let's go over the prefixes. Here are the prefixes for covalent compound. Ready? Hopefully you know most of them already. One is mono, and we usually omit one. We usually omit one except for carbon monoxide. Carbon monoxide is almost a street name, we use it. But we usually omit mono, we don't say it. Two is, hopefully you're shouting the answer, di. Three is tri. Four is tetra. Five is penta, right? Like pentagon, it has 5 sides. 6 is, if something has 6 sides, what do you call it? Hexagon. So 6 is hexa. So after 4 they get easy. Hopefully you know most of them. 7 is hepta. 8 is, what do you think? Octa. You guys remember that reality TV show Octa Mom? She had 8 kids. That's how I remember Octa. You guys don't watch reality TV show? I keep up with all the Kardashians. You can judge. There's nothing else on TV. Now, how about 9? What do you think? Nona. And 10, deca. So, these are the prefixes. I'm going to use prefixes to name covalent compound. So far, so good. Okay. And don't forget, we omit mono most of the time. Now, I give you examples of covalent compound at the beginning. I said carbon dioxide. I said CO2. Okay, that was a covalent compound. I said N2O. And I said B2O3. They don't have to have carbon, but a lot of them do have carbon. So these are covalent compound because they have 2 nonmetals together. So when you see compound, figure out, first of all, is it ionic or is it covalent? If it's covalent compound, then to name it, you have to use prefixes. So this would be carbon dioxide. Okay, so you do have to change the ending to "ide," the same as before. And I only have 1 carbon, I omit mono, I have 2 oxygen, so it's carbon dioxide. Alright, do this one before I do it. What do you think? I have 2 nitrogen, so dinitrogen oxide. Dinitrogen oxide. Again, I use 2 and I end up with oxide. And you can omit mono. How about this one? Diboron. How many oxygen I have? 3 trioxide. So when you see 2 nonmetals together, you go, that's a covalent compound. What am I going to use? I'm going to use prefixes. I'm going to use prefixes to name them, and the ending will also end with "ide." You guys feel pretty good about this? Okay, so covalent compound, so much easier than ionic compound. We're done with covalent compound. Ionic compound took 2 lectures, and then this one we're done. So no balancing of charges, it's just prefixes. That's all you gotta do. Now there's one last thing to talk about covalent compounds. So I lied when I said we're done. And then we can move on to the next set of compounds. Write this down for me. Let's see. H2, N2, O2, F2, Cl2, Br2, and I2. What we call this atomic molecules. Now, diatomic molecules, this is how they exist in nature. And again, you have two nonmetals together. When we say right now, you are breathing oxygen gas. When I say you're breathing oxygen gas, what do I really mean? I really mean O2, because that's how you exist in nature. When I say you're breathing in hydrogen gas, what do I really mean? I really mean H2. So notice, these are diatomic molecules. That's how they exist in nature. So right now in this room there is oxygen gas, nitrogen gas, hydrogen gas. What I really mean is H2, N2, O2. Now, do I use prefixes for this? Do not do that. I don't say dioxide or dihydride or dinitride. No. Don't use the prefixes for this. These are called diatomic molecules. This is how they exist in nature. So we don't use the prefixes. And every time I say oxygen gas, I mean O2. Every time I say hydrogen gas, I mean H2. That's how they exist in nature. So far, so good. Now, one thing to kind of remember, I still have my periodic table over here, which is stuck now. Okay. And it's actually pretty easy to remember them because they make an upside down L on a periodic table. So it's N, O, F, C, L, B, R, and I. You see kind of like an upside down L. So it's hydrogen and then an upside down L. This one right here, you see the green over here? These are my diatomic molecule and of course hydrogen. So my green over here, diatomic molecules. That's how they exist in nature. So even though two nonmetals together, I'm not really using the prefixes for them. Okay, now I'm done with covalent compounds, promise. What is the next one on the list? Go back to the first lecture. So it was ionic, which is a metal and a non-metal. Then it was covalent, two non-metal. What is the next one? Acid. Okay. Next one is acid. Acid comes from a Latin word, acidus. And what acidus means, it means sour. It means sour. Now, tell me some of the acidic food that you eat all the time. Oranges, right? Grapefruit. Those are all acidic food and they taste sour. And every time I ask this in class, someone says Sour Patch Kids. No, they're not acidic. They're not real acid. So any fruit, any citric fruits that you consume, those have a sour taste, and that's because of their acidic food. Now, how do you know you have an acid? When you have an acid, you have a hydrogen, and then you have an anion. And remember, the anion are basically the nonmetals, right? Because the nonmetals, they like to gain electron. So you have a hydrogen and you have an anion, you have a nonmetal next to it. That's how you know you have an acid. Acid starts with H. Write it down. Acid starts with H. And acids are technically under ionic compound. And the reason for that is what you have to do, you have to balance charges. You have to balance charges for acid. You have to balance the charges for acid. You have to balance the charges for acid. Are we good right now? So, okay, I need to erase this because I need more room. Now, as I'm erasing this, let's repeat this together. How do you know if you have an acid? Starts with H. Anything that starts with H in this class is going to be an acid. And then it has an anion next to it. And for acids, don't forget, you have to, what do you have to do? You have to balance the charges. That's really key. You have to balance the charges. Then we're going to talk about naming acids, okay? Here's how you're going to name the acid. You're going to name the nonmetal anion. Name the nonmetal anion, okay? If it ends with, so you're going to name the non-metal anion. If it ends with "ide," okay, then what's going to happen is going to be hydroic acid. If it ends with "ate," then it's going to be ic acid. If it ends with "ite," then it's going to be os acid. And this is gibberish to you right now. You have no idea what I'm talking about, and that's okay. I haven't done any practice problem. I just wanted you to put down the rules. So here is the rules for naming acids, okay? Here's the rules for naming acids. Now we're going to do practice problem to show you how you would name acids. Ready? Okay, let's do this. So I'm going to write down these acids. Write them on top of each other for me. HBr, HCl, HNO3, and then HNO2. We're going to name this together. Are you ready? So HBr. So you have to name the anion first, right? The non-metal ion, because non-metals usually gain electron, they become an anion. So what is Br? Remember, when Br is an anion, you usually end with ide, right? So this is bromide. This is bromide. Do you agree? Okay, because Br minus is bromide. So it ends with what? It ends with ide. It ends with ide. If you end with ide, you're going to be hydroic acid. So this would be hydrobromic acid. So this would be hydrobromic acid. Okay. Don't worry, you're going to get the hang of it by the time we're done with this. HCl. What is Cl? Is chloride, right? Cl minus is chloride. It's a non-metal, it's an anion, because non-metals don't want to gain electron, they become anion. So Cl is chloride. Is chloride. So if you're ide, you're going to become hydrochloric acid. Hydrochloric acid. Hydrochloric acid. You're going to become hydrochloric acid. You good so far? Okay. HNO3. What is NO3? So hopefully you shouting right now, that's a polyatomic ion. Yes, it is. What is it? Look at your polyatomic ion chart. NO3 is nitrate. Nitrate. Okay? NO3 is nitrate. So it ends with 8. If I end with 8, there is no hydro. If I end with 8, I become ic acid. So nitrate becomes nitric acid. Becomes nitric acid. Again, because I ended with 8, if you end with 8, you just become ic acid. So this will be nitric acid. Okay, ready for the next one? Next one is HNO2. What is NO2? Polyatomic ion. Which one it is? Nitrite. We said when you have one less oxygen, H becomes ite. So, nitrite. So it ends with ite. If I end with ite, I become os acid. I become os acid. So what is this one? This one would be nitrous acid. This one would be nitrous acid. You guys are following me so far? Okay. This one would be nitrous acid. Okay. Now, I want you to look at all these acids that we just did. All these acids that we just did, how many hydrogen do they have? HCl, HBr, nitric acid, nitrous acid, how many hydrogen do they have? They have 1 hydrogen. Do you agree? 1, 1, 1, 1. So what we call this We call this mono. Mono means one. Monoprotic acids. So monoprotic acid means they have one proton. Proton means H plus, okay? It has one proton. It is a monoprotic acid. Sounds good? You guys got this down? Okay. Ready to do more practice problem? Let's do more practice problem. So acids, how do you know you have an acid? Starts with H, right? Starts with H. And then you use this rules to name the acids. So you know how they say like acid is sour? When I was an undergrad, when I was like you guys, I was in chemistry lab and I did not wash my hands. Wash your hand before you leave any chemistry lab. And I had hydrochloric acid on my fingers. And I put my fingers in my mouth. It had a sour taste to it, but it also burned my tongue. And I had a hard time talking for a couple of days. I had a roommate who used to get migraine, and her migraine was gone that week that I couldn't talk. I'm sure there's no correlation. But yeah, so I can tell by experience that acids they have a sour taste. But do not try that. Wash your hand after that. Ready for more practice problem? Let's do it. H2SO4. Again, it's an acid, starts with H. H2CO3. H2SO3. You guys ready? Okay. Let's do this. So, we have to name the anion first, right? SO4. What's SO4? Hopefully you're shouting that SO4 is a polyatomic ion. I completely agree. Okay, if you look at your polyatomic ion chart, what's the name for SO4? Sulfate. So it ends with 8. If you end with 8, what are you going to become? Ic acid. So this becomes sulfuric acid. Sulfuric acid. You don't use hydro. Hydro is only when you end with ide. So 8 becomes sulfuric acid. CO3. What is CO3? CO3 is polyatomic ion, is carbonate. Carbonate. Okay? Is carbonate. So carbonate ends with what? Ends with 8. It ends with 8. So if I end with 8, what am I? Carbonic acid. You know how like I told you probably are complaining about memorizing the polyatomic ions, but they're everywhere. So carbonate and carbonic acid. Where have you seen that word before? Carbonic drinks, right? You have carbonated drinks. And some of the sodas, what they have in them, they have carbonic acid. So next time you're drinking a soda, think about it. It was like, oh, I know what's in there. I can write down the formula. Ready for next one? H2SO3. H2SO3. What's SO3? Polyatomic ion. If you look at your polyatomic ion chart, is sulfite. Even if you didn't know that, SO4 is sulfate. When you have one less oxygen, becomes I. Okay, so I have sulfite. If I have sulfite, ends up being acid. So what is this one? Sulfurous acid. Sulfurous acid. Okay, hopefully you feel pretty good about this. Now, look at these acids that I just wrote down. Let me just do practice. If you look at all these acids, how many hydrogen do they have? 2, 2, 2. These acids that I just wrote down, they have 2 hydrogen. So what category would you give them? 1 hydrogen was monoprotic acids. This would be di is 2, so diprotic acids. Is diprotic acid because it has 2 hydrogen. Di means 2, product means H plus, so proton or hydrogens. So diprotic acids. You're good? Okay. So now what I'm going to do, I'm going to give you a practice problem to do. And you're going to do the practice problem while I'm erasing the board. Here is the practice problem I'm going to do. I'm going to get fancy on you. phosphoric acid. Write down the formula for phosphoric acid. So write down the formula for phosphoric acid. Alright, you do that, and I'm going to erase the rest of the board. Phosphoric acid. Write the formula for phosphoric acid. Okay, so the first thing you're going to say phosphoric acid is an acid. So every time you know you have an acid, what is it going to start with? It's going to start with hydrogen. It's going to start with hydrogen, okay? Now, phosphoric acid. Phosphoric acid is ic acid. What does it used to be? It used to be 8. So if I have phosphoric acid, I know I have an acid, so I have to put a hydrogen, okay? Ic used to be 8, so it used to be phosphate. It used to be phosphate. Remember, all the 8 and 8 are polyatomic ions, right? Every time you have 8 and 8, they're polyatomic ions. So go to your polyatomic ion sheet and tell me what is phosphate. Phosphate is PO4. So every time 8 and 8, those are for polyatomic ions, right? Those are the ones that end with 8 and 8. Now, okay, remember what we talked about? We said acids, you start with H, and you have to balance the charges. For acids, they're technically under ionic, you have to balance the charges. What's the charge on hydrogen? Hydrogen is in group 1A, so the charge is +1. What is the charge for phosphate, the polyatomic ion? If you look at your polyatomic ion sheet, you see that the charge on phosphate is -3. You have to balance the charges, the same as ionic compound. You have to balance the charges. So when we balance the charges, we don't write the 1, right? What I end up being, it would be H3PO4. H3PO4. Okay. Now, let's quickly summarize acid. You know you have an acid, but it starts with H. You see, acid starts with H. Okay? Now, acid, when you write the acid, you have to balance the charges, just like the ionic compound. You have to balance the charges, just like the ionic compound. And for naming the acids, those are the rules to use for naming the acid. Now, one thing I want you to keep in mind, a little bit of shortcut. When you have 8 and 8, those are polyatomic ions. Go straight to your polyatomic ion chart. Ide, those are simple ions. You take it from the periodic table, right? Those are mostly simple ions. You take it from the periodic table. Okay. Now, what category would you give this acid? H3PO4. What category would you give it? How many hydrogen does it have? 3. So it would be under triprotic acid. It would be under triprotic acid because it has 3 hydrogen. We're good? Okay, so acid starts with H. Don't forget to use that to name the acids, and you have to balance the charges for acid. Now, I was going to move on, but I want to give you one more practice problem before moving on. I have a hard time moving on. I got to give you more practice first. HI. Quickly name that for me. HI. Okay. So I go with, what's I? I is a simple ion from the periodic table, is iodide. Again, 8 and 8, those are from polyatomic ion. But most of the ide, those are simple ions. You take it from the periodic table and the ending ends to ide. So that's iodide. If you end with ide, so what are you? You are hydroiodic acid. So simple ions that you just take from the periodic table, like Cl, like F, like I, the ending will always be ide. So like HI, those would be hydroiodic acid because this is iodide, hydroiodic acid. Good? Okay. I feel better that we do one more practice problem. Okay, let's do this. Let's look at the last part. So, we've done ionic. Ionic is a metal and a non-metal. We've done covalent, which are two non-metals together and a shared electron, and you have to use prefixes. We've done acids, which starts with H. What's the last one to do? Last one is base. So we said acid starts with H, and base is the easiest one to do, okay? So it's the easiest one to do. Acid, they start with H. Base, they end with OH. So it's a cation. So you have a metal, because metals they lose an electron and they become cation. So you have a metal and then you have an OH. You have a metal and you have an OH. That's it. And just like acids, bases are all technically under ionic, so you have to balance charges. So you have to balance charges. So basically for ionic compound, for acid and bases, you always balance charges. For covalent, you do not balance charges, you use prefixes. Okay. Now, what is OH? I want you to look at I want you to look at your polyatomic ion sheet and tell me what OH is. If you look at it on a polyatomic ion sheet, this is hydroxide. It's a polyatomic ion. It's a hydroxide. So acids, we talked about acidic food. You consume a lot of acidic food. Bases, where would you use bases? If you guys ever clean, all the cleaning supplies are actually basic, and they have a slippery feel to them because of their OH. So the next time you're cleaning, think about this. The cleaning supply you use is a base probably. All right, let me give you some practice problem to do. KOH, I want you to name this. Name KOH, name CaOH2, and I want you to write the formula for aluminum hydroxide. Pause me, do this, and then we're going to go over it together. So pause me, do this, and then we are going to go over this together. Okay. KOH is a base, right? That's the first thing you should think about. When you see compound, is a base, acid, covalent, or ionic. What is K? K is potassium. What is OH? OH is hydroxide. So potassium hydroxide. So bases, you treat them just like ionic compound for naming and writing. You have to balance the charges and you name them exactly the same way you would name ionic compound. And OH is hydroxide, polyatomic ion. What is this one? Ca is calcium hydroxide. Calcium hydroxide. So far so good? Okay. Now this one, I asked you to write a formula. Aluminum. What is aluminum? Aluminum is Al. Okay. Hydroxide is a polyatomic ion. You know that. It's OH. Okay. Now we said for bases you have to balance the charges. Aluminum is +3 and OH, look at the polyatomic ion chart, OH is -1. So it's +3 and -1. What are you going to do? You're going to balance the charges. If you balance the charges, you get AlOH3, aluminum hydroxide. AlOH3, aluminum hydroxide. Sounds good? Okay, aluminum hydroxide. Alright, there's one last thing I want to do, so we're done with naming, and then next session, we're going to do nothing but practice problem. Okay. As I'm erasing this, I'm going to summarize everything. You take notes or like listen to me and repeat after me. So we can have ionic compound. Ionic is a metal and a non-metal. You have to balance the charges, and then we've gone over the naming. Covalent, which we did today, was pretty easy. Two non-metals together. There are no charges. There's no balancing of charges. We have to use prefixes. Acid. How would you know you have an acid? Starts with H. And the naming, you know how to name the rules. An acid, you have to balance the charges. It's technically like ionic compound. Bases, how do you know you have a base? Ends with OH. The same thing as acid. So your naming and the writing is just like ionic compound. You have to balance the charges, and then you can name it just like ionic compound. So far, so good. Last thing. Last thing we're going to talk about. Now we talked about acid and bases. We're going to talk about a strong acid and bases versus weak acid and base. So we're going to talk about strong acid and bases versus weak acid and bases. So when we talk about acid and base, what really matters is if an acid is a strong acid or an acid is a weak acid. That really matters. Now we're going to go over what does it mean to have a strong acid and what does it mean to have a weak acid, and also for the base also. But the acid is the one I want to focus on. Strong acid. So if I have a strong acid, what does it mean to have a strong acid? This is what it means. Strong acid would completely ionize in water. You guys know H2O means water, right? It will completely ionize in water. Well, what the heck does ionize mean? Ionize is nothing fancy. Ionize means break up. It's a fancy way of saying it would break up. It would dissociate in water. Next time you want to break up with someone and you don't want to use the word break up, guess what you can say? You can say, let's ionize. It sounds so much better than break up, but it's just like ionize. And if you have no idea what you're talking about, which means they did not take care of it, you should break up with them anyway. Alright, see, I'm teaching you life lesson 2. Ready to do this? So, strong acid, they would ionize completely in water. I'm going to give you an example. An example would be hydrochloric acid, HCl. Hydrochloric acid is a strong acid, okay? It's a strong acid. Because it's a strong acid, it's going to have 100% dissociation. It's going to have 100% dissociation. It would completely break up in water, and it would break up into H plus and Cl minus. It would completely break up in water. It would ionize. So far, so good? So, HCl is a strong acid. It would completely break up. Now, what makes an acid to be an acid, what is responsible for that sour taste, is the H plus. So, HCl is a strong acid because every single hydrochloric acid is going to break up into H plus. You end up having a lot of H pluses. And that's why it's a strong acid, because you have a lot of H pluses, and H plus is what makes something to be an acid. It's responsible for the sour taste. So far, so good? Okay. Now, what do you think a weak acid then is? It would partially ionize in water. It would partially break up in water. Okay? It will have a partial dissociation. Okay? Now, an example that I like to use is HF. Now, before I do this, here's what I need you to do. I need you to do this. I need you to name HF for me. Do it right now. I'm waiting for you guys. Okay. So, F, simple ion from the periodic table, is fluoride, right? because all of those simple ions from the periodic table, they end with "ide." So it's fluoride. If you end with "ide," what are you? If you end with "ide," your hydro is hydrofluoric acid. Is hydrofluoric acid. Okay, good. So hydrofluoric acid is a weak acid. Now, when you have a weak acid, you're going to put a double arrow. You're going to put a double arrow when you are a weak acid. Now, let's go over what does it mean to be a weak acid. So hydrofluoric acid is a weak acid. What that means is it would only partially dissociate in water, okay? So, for example, if I have 100 hydrofluoric molecules, maybe 90 of them, 95 of them are going to stay together, and 5 of them, for example, would break up. So most of them actually stay together, but some of them will break up. If I have hydrochloric acid, if I have 100 hydrochloric acid molecules, every single one would break up. But if I have 100 hydrofluoric acid, 95 of them are going to stay together. Maybe 5 of them would break up into H plus and F minus in water. So it's a weak acid because you won't have as much as H plus as you would have with hydrochloric acid. Okay, so strong acid would completely break up, weak acid would only partially break up. So far so good? Okay. How would you know if an acid is a strong acid or is a weak acid? How would you know? Glad you asked that. Here's how you would know. I want to give you a list of the strong acid. We have 6 strong acid, everything else is considered weak. So here are the strong acids. You ready? You have to put these down somewhere safe. Hydrochloric acid, HCl. Hydrobromic acid, HBr. HI, hydroiodic acid. Nitric acid, HNO3. HClO4 and H2SO4. These are the strong acid. Everything else is considered weak. If you have one of these, strong acid, everything else is considered weak. So put a circle, highlight it, take a picture of it, know these ones, everything else would be considered weak. Alright, so we're done, but I'm gonna leave you with one fun fact. We'll always do a fun fact to make sure you come back the next time. Hydrofluoric acid. Hydrofluoric acid, strong acid or weak acid? Weak acid is not one of these acids. Let's say a hydrochloric acid, strong acid. Let's say nitric acid, strong acid. If you get those acids on you, will you die? Probably not. It's gonna leave a scar maybe. It's gonna burn a little bit, but you'll survive probably. Hydrofluoric acid, weak acid. If you get hydrofluoric acid on you, you're dead. Isn't it interesting that the strong acid cannot kill you, but the weak acid can kill you? What's going on with hydrofluoric acid? Hydrofluoric acid has fluoride. Your bones have calcium. Fluoride loves calcium. If you get hydrofluoric acid on you, you probably won't even know because it's a weak acid. It's not even going to burn. But if it gets to your bone, it's going to start eating your bone, and then you're dead. Very painful death. So it's kind of interesting to me that a weak acid can kill you, not the strong acid. Now, I can imagine your faces right now. Don't worry. On no university campus is going to have hydrofluoric acid on campus. But it's kind of interesting to know that it would eat up your bones. Now,